You're welcome to another episode. In this video, we're going to discuss about injective, surjective, and bijective functions. You're also going to go ahead to do some examples so that you understand really what an injective function is and how to identify it, surjective and bijective. So for the first section, we have the three diagrams to illustrate how injective functions, surjective, and bijective functions behave. Right. So the first one, we have that x1 maps to y2 and x2 maps to y1. Well, here the definition of function is satisfied that every element in the first set must correspond to exactly one element in the second set. But a little bit of a thing here is that for an injective function, different values in the first set cannot have one output. That is, different inputs which are different elements in the first set cannot correspond to one element in the second set. That's one thing about injective function. So let's have the definition real quick. So the definition of an injective function, well, another name for an injective function is a one-to-one function. So we start off by saying let f be a map from a first set x to a second set y. Then f, which is a function, is said to be a one-to-one function. All right, if and only if for two elements in x, that is for x1 and x2, which are members of the first set x, the value of the function evaluated at both values, if the value of the function evaluated at both values are equal, that is at x1 and x2 are the same, it means that x1 and x2 are the same. Such a function is said to be an injective function. We can also say if two inputs are different, then given that the function is a one-to-one function or an injective function, the values of the functions will also be different. So you don't have a case or a situation where two different values in the first set have the same result. So maybe as an example, I would like you to look at this one. So let me see. Oh, I didn't make an illustration for that. So let me show you what a typical example would look like. So assuming here we have y3. Let's say we have y1, y2. Let's say we have y3 somewhere. Right? Good. No, it shouldn't be y3. I'm coming. Okay, so let's say we have x3. Yeah, that's nice. Good. So x3 corresponds to, let's say, y2 as well. Let's say x3 also corresponds to y2. So what happens here is that we have two values in the first set, that is x1, okay, and x3 correspond to the same thing. x1 corresponds to y2 and x3 also corresponds to y2. So in this case, we have two different inputs or two different elements in the first set, that is x1 and x2 being different, but they correspond to the same thing. In other words, their values are the same. So such is not an injective function. That is why this is the representation. Now coming over to the surjective function. Now don't get it wrong by saying that, okay, whenever a function is not injective, therefore it is surjective. No, that is not true. Sometimes a function may be may not be injective and not be surjective. So what do we mean by surjective function? Well, a function is said to be surjective when every element in the second set has a pre-image. So let me explain a little bit of what I mean by a pre-image. So coming down here, when we have this equation f of x equals to y, x here is the pre-image of y, while y is called an image of x. So that's the difference. When you evaluate a function as some input value like x and you get a result, that result is the image of the input. Meanwhile, the input can be seen as a pre-image. Okay, so by the word pre, you understand what that means. Good. So if every element in the second set has a pre-image, then such a function is said to be a surjective function. So in other words, another way of thinking about it is that everything here is being mapped to. A bijective function is just a combination of both. If a function is injective and also surjective, then such a function is called a bijective function. So that means that every element in the second set has a pre-image, and also each element corresponds to exactly one. That is, no two distinct elements in the first set has the same value. Okay, I've just explained briefly what surjective functions and bijective functions are, but we still have their definitions here. Good. So for the surjective, the definition is this: given a map from a first set x to second set y, then such a map, which is f, is said to be an onto function if for each element in the second set there exists an element in the first set such that this equation holds. So again, every element in the second set has a pre-image. That's what I mean by this thing means there exists. So let me write it out for you. It means there exists. Okay, so just a symbol I'm making use of. There exists, that is, there is a certain element in the first set such that is as a pre-image, right? That works. So quickly, a bijective function, a function is said to be bijective if it is both one-to-one and onto. Yeah. So in that case, being one-to-one and being onto, they're not mutually exclusive if you want to think about it that way. That is, being onto doesn't stop the function from being one-to-one, right? Good. Remember, one-to-one is an injective function. A surjective function is an onto function. Those are different names. Anyway, so here we have some examples. So this is the first example you're going to do. So for this first example, what we have here is that f is just f is a function. When evaluated at some x, what it does is that it will square x, multiply by 2, and then subtract 1 from the result. So we want to show whether this function is injective and whether it is surjective. So I'm not going to use the definitions in this example, but rather I'm just going to use those kind of diagrams. Okay, so let me start off with a solution. So as a solution, no, I don't want to use this ink. Okay, so let's just write solution here. Okay, so this is what I'm going to do. So for the first one, we want to check whether this function is injective. Anyway, it's not really the first. Maybe we can do the two of them at once. So this is what I'm going to do. I'm going to draw those circular shapes. Okay, not really circular, but I'm just going to draw the shapes. Then for the first set, which is x, we have -1, we have 1, and then we have 2. For the second set, which is y, we have elements from -2 to 5. So maybe let me clean this and make it better. So we have elements from -2 to 5. So let me draw that. Good. That is from -2 to 5, but -2 is not included. Look at the strict inequality. So it's strictly greater than -2. That means we're going to start with -1. Then it goes down, or it goes up to 5. So after -1, you have 0. We have 1, 2, 3, 4, and then 5. And why I'm listing them is because they are integers. So this is a set, using set builder method. Say y is a set containing every integer x such that such integers lies between -2 and 5, with -2 excluded and 5 included. Good. Okay, so given the rule, which is 2x squared minus 3, what we're going to do is to evaluate this function for each of these values of x. So when x is -1, what happens? Okay, we evaluate the function when x is -1. Okay, so we're going to say the function evaluated at the value of x being -1 is what? Okay, good. So this is what we're going to get. We're going to get 2x squared. That is, we're going to square the input minus 3. So where the input here is -1, but well, -1 squared is 1, and 2 times 1 is 2 minus 3, that is -1 as a result. When we simplify this, that means -1 corresponds to, is that -3? Sorry, what did I say? Sorry, let's look at that again. -1 squared, this is 1. When we evaluate that, 2 times 1 is 2. 2 minus 3 is -1. Okay, so that's -1. What that means is that -1 corresponds to -1, because we put -1 as an input, and then we get -1 as a result. Good. Okay, so we're going to do for the second value of x. So when x is 1, what happens? Okay, so the value of the function evaluated at 1 is what? So when you put 1 into the function, that means this is going to be 2 into 1 squared minus 3. Okay, but 1 squared is 1, and then 2 times 1 is 2, and then 2 minus 3 is -1. So again, this one shows us that -1 also corresponds to -1. And then lastly, when x is 3, I'm not going to write, just look at it. When x is 3, you put 3 into this function. That's wherever you find x. So 3 squared is 9. Is it? Sorry, when x is 2, okay, put 2 into this function. That will be 2 squared is 4, or 4 times 2 is 8. 8 minus 3 is 5. What that means is that 2 corresponds to 5. Good. Okay, so here's a question. Is this function injective? Okay, good. So what do you mean by injective function? From the definition that two distinct values in the first set cannot have the same the same result. So -1 and 1 are different, but their outputs are the same. Remember, -1 gave us 1, and minus and 1 gave us -1 as well. -1 gave us -1, and 1 is giving us -1 as well. So since f of -1 is the same thing as f of 1, okay, it means that f is not injective, because it contradicts the definition of being an injective function. Okay, the definition tells us that different inputs should have different results. Okay, so we want to answer the question of being surjective. So is this surjective? Remember, for the definition of being surjective, say that if every element we say that if every element in the second set has a pre-image, but clearly you see that 0 has no pre-image. In other words, there is nothing from this x value that gives us 0. 1 has no pre-image, 2 has no pre-image, 3 has no pre-image, 4 has no pre-image. So since it is not every element in the second set that has a pre-image, it means that the function is not surjective. Good. So that is a way of saying, because it is not injective doesn't mean it doesn't mean it is surjective. It is not injective and it is not surjective. So that is it. Now let's do one last example. But this example, okay, so for the next example, we want to show whether this function f of x equals to x plus b, where a is non-zero, is bijective. So that is a linear function, all right? Good. So to show whether this function is bijective, we have to show it is whether it is injective or surjective. Remember, for a function to be bijective, it has to be both injective and surjective. Yeah. So this is going to be like two parts. Good. So we start off with the first part, which is to check whether it is injective. And if the function breaks down at any of them, that is, when you check whether it's injective, it's not injective, then therefore it's not bijective. Okay. Yeah, so what can we do? Well, what do you mean by a function is injective? So I want to show whether the function is injective, and that will be based on the definition of an injective function. But first of all, I want you to realize that this is a linear function, and the domain of a linear function is the set of all real numbers. The range is also the set of all real numbers. So in that case, we say let f be the map. So f takes R to R. So the first set is going to be a set of real numbers, and then the second set is going to be the set of real numbers. That is for linear functions. Okay, so you can check the graph of the function, or you read the domain of linear functions, and you will see that out. Anyway. Okay, so that means the first set will come from a set of real numbers. So this is what I'm going to say. To show it is injective, that means you want to show that okay, that the function is 1-to-1, okay, if and only if for two values, let's say x1 and x2 in R, that is for two real numbers in the domain, the value of the function evaluated at x1 is the same thing as the value of the function evaluated at x2, means that x1 is the same thing as x2. That is from the definition. All right, good. So using that, so that means we're going to assume that this left hand side is true, that this equality is true, and then we'll check if that leads us to saying that x1 and x2 has to be the same. Sorry, that x1 and x2 have to be the same. Okay, so what does it mean for f of x1? F of x1 means when the function is evaluated at x1. So f of x is ax plus b. So f of x1 will be ax1 plus b. Similarly, f of x2 will be ax2 plus b. That is when you substitute x2 for x. Okay, their equality would imply that. So f of x1 equals to f of x2 means that this left hand side, which is ax1 plus b, is the same thing as ax2, sorry, that's supposed to be ax2, okay, ax2 plus b. But from this equation, we can solve for the value or we can try to get something out. So what I'm going to start off with is subtract b from both sides. So you notice that we subtract b from both sides, they will be left with ax1, because b minus b will break down to 0, b minus b will break down to 0, the equality sign, then we have ax2. Then the next thing I'd like to do is to say divide both sides by a. Divide this by a, and then divide this by a. A cancels out with a cancels out with a, leaving us with x1 equals to x2. So x1 equals to x2 using, so you notice what we have. We started by assuming that f of x1 and f of x2 are the same. That leads us to saying that x1 and x2 has to be the same. That x1 and x2 have to be the same. So what that means is the value of the functions, okay, the value of the functions are only equal when the inputs are equal, otherwise they are not. Okay, so that is it. That shows that the function is injective from the definition. So we can say therefore f is injective. So yeah, then the next thing is to check whether it is surjective. So let's do that right here. So okay, so for surjective, that's the b part. Okay, so you want to show whether f is surjective. So remember that every linear function is defined on the set of real numbers, and then the result will also be in the set of real numbers. That is, the domain is the real numbers, and then the codomain is the set of real numbers as well. Okay, so what do we mean by a function is surjective? So you want to show that, so this is what we want to show. We want to show that for every y in the codomain y, that there is a certain x in the domain such that this equation holds, so that f of x is equals to y. Good. So we're going to start off with this equation, f of x equals to y. Then we are going to try to see if we will find an x in the set of real numbers. That if we can find a real number x, given that f of x is equals to y. Okay, so let's start off with the equation. What does it mean for f of x to be equal to y? Based on the function f of x equals to y means that since f of x was defined as the linear function ax plus b, and besides I forgot to point out that here we can only divide both sides by a because a is non-zero from the definition of the function. Okay, so let's get back to this. Good. Now here we have that the function is, that means ax plus b, which is the definition of the function, is equals to y. So here let's try to see if we can find x as a real number so that this will make sense. So this is ax equals to y minus b. We divide both sides by a. Again, this is possible because a is non-zero. So when we divide both sides by a, we'll be left with x equals to y minus b over a. Now a is non-zero, so it is possible. Y is a real number, so what we have here is that a real number y, you subtract b, which is a constant real number, from y, which is a real number, and then we divide the difference by a non-zero real number. So in fact, x is a real number. So this means x is a real number because this right here is a real number. So what that means is that for any y in the codomain, which is the set of real numbers, we can find a real number x such that this equation f of x equals to y holds. Good. So what that means is that f is surjective. So the function is surjective and it is injective, therefore the function is bijective. And this is a very general result for any linear function, that any linear function is surjective and bijective. And a linear function is defined, it has this form where this a is non-zero. Okay, if a is 0, then such a linear function becomes a constant linear function. But that is a case where a is 0. So for any linear function in which the coefficient of x is non-zero, then such a linear function is a bijective function. Okay, that was a lot. I hope you enjoyed the video. If you have any questions, put the question in the comment section below, and you get a reply as soon as possible. Thanks for watching. Please don't forget to share the video with your friends, subscribe to my channel, and we'll continue from my next video.